All right, here we go. Now, this one's understanding the standard deviations. Biggest idea in the whole course. You really have to understand this measure of spread. It kind of tells you how spread out data is. I'm going to walk you through a few steps so you can conceptually grasp what this thing is, so that when you're using it in problems, you kind of know what it is. And hopefully, I can walk you up through to the point where you understand that crazy formula and understand what it's actually saying. Because once you get it, you're like, oh, well, why was that so confusing? It's at first it is, and anything you're going to learn in this course, at first it's like, what? A lot of math. It's like, the first time you see it, you're like, and then the second time you see it, you're like, and then the third time you see it, you're like, oh, I think, and by a few times later, you're going, how the heck did I not understand that 7 times ago? So hopefully I can get to that point. It's going to be probably a long video. I got to go through a lot of steps, but be patient. I'm hoping by towards the end you can go, ah. So let's talk about this thing, standard deviation, understanding the standard deviation. So what I'm going to do is I'm going to just erase this right here. I'm going to put a data set up there, and I'm going to ask you some questions, okay? So here's the data set I'm going to deal with. The data set is the data set 1, 2, 3, 4, 5. And I'm going to ask you a question. What's the mean? Well, if I add this up, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, 15, divided by 1, 2, 3, 4, 5. Ah, the mean is 3. So we know this. Mu, we'll say this is a population, equals 3. Okay, so I found the mean. Now here's a question I'm going to ask you. What is the average distance to the mean? Now you're looking at me like, what? And I ask my students, what's the average distance to the mean? And I leave that on the board. Generally, nobody writes anything. So then I'll lead to the next one. Well, how far away is 1 to the mean? It's 2 away. How far away is 2? 1 away from the mean. There's the mean. How far away is 3? So this is what you do. To find the average distance to the mean, you have to ask each value, hey, how far away from the mean are you? So that's what I'm going to say. Ready? Hey, how far away from the mean are you? I'm 2 away. Okay, how far away are you? I'm only 1 away. You. I am the mean. I'm like right there, buddy. What about you? How far away are you from the mean? I'm the same distance as 2. Yeah, that's a puzzle there. 5. How far away from the mean are you? I'm 2 away. So these are all of the individual distances to the mean, right? The individual distance to the mean. So if I want to find the average distance to the mean, it's the average of all the individual distances to the mean. This guy's 2 away, 1 away, 0 away, 1 away, 2 away. I add them up and divide by the number of distances. 2, 3, 4, 5. 2 plus 1, 3. 6 over 5, which is 1.2. So on average, they're all 1.2 away from the mean. So the average distance to the mean here is 1.2. That's the standard deviation. Not exactly, but for now, that's what I want you to think about the standard deviation. It's about the average distance to the mean. About, sort of. So it's the average distance to the mean. So if I ask you, what's the standard deviation? You say, it's the average distance to the mean. You ready? Just say it. I know you're sitting at your computer. Ready? What's the standard deviation? I couldn't hear you, but I'm hoping you said the average distance to the mean. And it's put it into words and say it. The standard deviation is the average distance to the mean. About. I'm going to get to that about part. So we calculated that. And if I was going to make a formula for what we calculated, it would be tough. Like I added up, let me think of what we did. Let's go back to how we calculated the mean first. Added all these guys up. We added up every individual x and then divided by n. And that's what that sign sigma means. It means add up every one of these things. So when you see the summation, there's going to be as many things as there are values. So this means take each individual, 1, add it to the next individual, 2, the next 3, add them all up and divide by n. N is always the number of values, and in this case, there are 5. Add them up, 3, 4, 5, and divide by 5. So I have this symbol here, sigma. That's actually the definition. Mu is the sum of each individual value divided by the number of values. Okay. That's the definition of mean. Now imagine if like the first day in class, all right everybody, this is the mean, calculate the mean of this data set. You'd be like, what? So a lot of people haven't seen this yet because you haven't done sequences and series and all that stuff. But you'll get to that in Algebra 2, pre-calc and stuff like that. It's a cool little symbol. It's shorthand. If I was going to write this in words, mathematicians like this, I'd write, add up all of the individual values in the data set and then count how many values are in the data set and then divide the thing you added up before by whatever, how many there are. Like it's just a long sentence. This tells you, add them all up, divide by how many there are. Short and sweet. There's your mu. Remember, mu, it's a hybrid. It's half M, half U. It kind of looks like a U. It's like mu. All right, anyway, let's go. Let's see how we found the average distance to the mean. Notice what I did. I added up a bunch of things. I added up all the distances to the mean. In distance, we use difference. So I took each individual and I subtracted the actual mean from them, and I added them all up and divided by the number of numbers. So that's how I found the average distance to the mean, I think. Let's see. Each individual, there's 5 things. 1, 2, 3, 4, 5. I'm going to add them all up, put in the individuals, and divide by 5. Let's see if that's how I found the average distance to the mean. Each individual, so everything, I'm going to subtract the mean from each one. That's what this thing says. It says, how far away are you? That's what this thing says. Hey, how far away are you? How far away are you? How far away are you? Subtraction. So 1 minus 3, 2 minus 3, 3. If I just put all the individual values, the i's for each individual. Let's see if that works. 1 minus 3 is negative 2. 2 minus 3 is negative 1. 3 minus 3 is 0. 4 minus 3 is 1. Wait a minute. Problem, if I add these up, I get 0. So this isn't actually what I did, because this number, this always equals 0. This is always 0 for any data set. So that's a problem. I want to know the average distance to the mean, and I got all these negative numbers. How can I get rid of negative numbers? Ooh, I can use the absolute value sign. Let's try that. So now it's saying, remember, absolute value is a distance function. Remember, it tells you, like, for any number, it tells you how far away it is from 0, right? And when you put the absolute value of A minus B, it always tells you the distance between them, because distance is positive. Like, I'm like 6 feet from the camera now. I'm not negative 6 feet now. It's like distance is always positive. So if I do that, then I get all the absolute values here. That becomes positive, positive. That's what I did. That calculates the average distance to the mean. So if you're going to calculate the average distance to the mean, you can do this. This actually has a special name. I call it the standard deviation, but it's wrong. I mean, it's the mean absolute deviation. It's the real and true average distance to the mean. This would be pretty much used. However, and this is the story I'm going to tell you, and hopefully it'll stick. Not 100%. It's good. Ready? Here we go. The problem with absolute value, which is true, is it's hard to manipulate algebraically. So statisticians are like, what else can we do to avoid all those negatives? But without using absolute value, what else could we do? I don't want to use absolute value because they said, oh, this would be great. Yeah, we will use absolute value. And they tried to manipulate it algebraically, and they were like, So we have to go back to the drawing board. We know that this thing always equals 0. So is there anything else I can do to a number to make sure there's no negatives? There's something what's the thing you do that, like, no matter what negative comes, no negatives, squaring. If you square any number, isn't the result a positive number? Yes, it is. So what we're going to do is, instead of just taking this subtracting, let's subtract it and square it. Let's do that, because that should prevent any positive. Let's see if that works. Ready? Each individual Let's add them all up. 1, 2, 3, 4, 5. And let's square all those differences in order to keep any negatives from coming out and canceling out and ruining our whole thing. We're trying to find this average distance to the mean. So let's try it here. 1 minus 3, 2 minus 3, 3 minus 3, 4 minus 3, 5 minus 3, all over n. Let's see, 1 minus 3 is negative 2 squared is 4. 2 minus 3 is negative 1 squared is 1. 0 squared is 0. 1, 4 divided by 5. I can put the 5 there. 4 plus 1 plus 1 plus 4. It's 10 over 5, which is 2. So I just found the average distance to the mean is 2. And wait a minute, I didn't just find the average distance to the mean, did I? That is the distance squared. So 4 is actually this is saying this. How far away from the mean are you? Square it. How far away are you? Square it. How far away? Square that 2. How far? You're going to be squared 2. And so your distance, square that 2. So what we actually have here is a bunch of squared distances. Therefore, this thing here is the average squared distance to the mean. That average squared distance actually has a special name, the variance. The variance is just the average squared distance to the mean. Now remember, I said we're trying to find this average distance to the mean. And right now I have the average squared distance to the mean. What can you do to the average squared distance to the mean to get the distance to the mean? What can you do to something that's squared to kind of unsquare it? Square root. When you take the square root of something squared, you get it again, like, right? The square root of x squared. The square root, you know this, like the square root of x squared is x. So the square root of the average squared distance to the mean should be the average distance to the mean. Look at it. The average x squared is x. So the square root of the average distance squared should be the average distance again. Yes, sort of. The square root of the average distance squared, this is a little bit complicated, but let's just think of it about it like this. That's the average squared distance. If I take the square root of the average squared distance, I'm pretty much back to the average distance. So, now I've just turned this into the standard deviation. The standard deviation is the square root of the average squared distance to the mean. This is what the formula says. Hey, first individual x, how far away from you are you from the mean? Square it. Plus, how far away are you from the mean? Square it. And you, square it, and you, square it, and you, square it. Let's add them all together. Divide by how many we have. We have the average squared distance now. Now I'm going to take the square root of that average squared distance and get me back to the average distance. Sort of. Yes, okay? So you can think about the standard deviation as the average distance to the mean. So let's calculate it for another data set. And this is for a population mean. Next video I'll explain the difference between the two. So here we go. I'm going to put another data set in there just for fun. 3, 4, 5, let me see, 6, 7. Let's find the standard deviation by hand using the formula. Ready? This formula looks like this. The sum of all of the individual distances to the mean squared. How far away are you? How far away are you? Now I'm finding the average of all of the squared distances. Then I'm taking the square root. And that is my mu. Sorry, no, that is my standard deviation of the population. So let's do it. Ready? What's the average here? First, let's find the average. 7 is 14, 20 divided. Oh, the average is 5. Mu equals 5. So let's ask everybody how far away they are. There are 4 individual values, so I'm going to add up 4 distances. 1, 2, 3, 4. And what I'm going to do is ask everybody how far. They're all going to be the distance to 5 because that's the mean. So 3 minus 5. How far away are you from the mean? I'm 2 away. Square it. How far away are you? I want to square it. How far away? I want to square it. How far away are you? Square it. Divide it by 1, 2, 3, 4. Oops. The number of values, which in this case, the number of values is 4. And then take the square root. 3 minus 5, make it 2 squared, so I have 4 plus 1 plus 1 plus 4 over 4. Still find the square root. 4 plus 1 is 5, and 5 is 10 over 4. 10 over 4. What's 10 over 4? Well, it's 2.5. 2.5 is the average squared distance to the mean. So when I take the square root of 2.5, second square root, 2.5, I get 1.58. 1.58, that's my standard deviation. It's the square root of the average squared distance, but I like to think of it as the average distance to the mean. These guys, look how spread out they are. On average, they're about 1.5 away from the mean, about. It doesn't deviate too far from that original one we did, if you really did it straight up. Let's just double check on my calculator. I'm going to put this list in L1, so I go to Stat, Edit, Clear, Enter, whoops, go to 2, all right, Clear, Enter. Let's add in 3, 4, 6, 7, 3, Enter 4, Enter 6, Enter 7, Enter. I'm going to do Stat, Calc, one of our stats. Here it is. Look at my standard deviation right there. Can you see it? Can you see it on there? 1.58. See that little sigma x down at the bottom? See, your calculator does it for you, but that's how you do it by hand. Please don't forget what the standard deviation is. It's the average distance to the mean. The way you find it is you ask everybody in the data set, how far away are you? Square it. How far away are you? Square it. How far away are you? How far away are you? The distance, square it, square it, square it, square it. Let's find the average of all those squared distances. So I get the average square distance, also known as the variance, and then I take the square root of the average square distance, and I'm back to just about the average distance to the mean. Hopefully that made sense.